TCP overview. TCP feature, we know the basic functional data segment assembly, establishing a session, reliable delivery, same order delivery, flow control, windowing. We'll discuss in a detail. Okay, TCP header, just to look the TCP header here. TCP header is source port and destination port. There is a sequence number, there is acknowledgement number, header, reserved, bit, window, urgent, checksum, option, application. So you can see there are many options are here. So it's a 20 bytes. Okay. If I say 20 byte, what does it mean? Anybody knows? Header mean, you know, when you do at the message coming from up to down layer, encapsulation, when you put the header, that's the TCP header we are talking about. It will be add on the data, each IP, each layer adding its own header. That's the header. So it has many information. You can see sequence number. If it's like first packet, second packet, third packet, fourth packet, the messages will send and receive in a sequence number. Acknowledgement number as well. So you can see there are many fields. Urgent, if it's an urgent message, if the window size is that, if it is reserved, it's a bit control. Options are there, so sequence number. So all these information in the TCP. It's a 20 byte overhead. UDP as mentioned here, no reliability, no flow control, no connection, and no order of order as well. So you can see, as compared to TCP header, the UDP header is very, very small. There is no reliability. It just deliver a message and say, thank you, God. If you deliver good, if it's not, then we deliver again. So there is no state. Less protocol means it does not see the state is coming and going. No state flow, state information capture, and is required in the best effort. Multiple separate conversation, as you can see. Okay, port number, very important one. The port number, the source ports and the destination port number. You know, each application at the TCP layer or at the transport layer, it uses the port number. And you can see the port number is also in the TCP header and also in the UDP header as well. Why you need port number? Because in order to track the different application, you know, we talk about the internet chat. First of all, discuss that the transport layer can keep different application data separately. How can it do that? So for example, you already open email, you have an open Exchange server, you have opened the web server as well, you are doing the file transfer, you are chatting someone in the Facebook as well. How this happen? Why the email is not overlapping with the chat you are doing in the Facebook? Because each port, each application you are using, it uses a separate port number. With the port number, your source and destination can keep the different application differently, uniquely open, and they can communicate to each window, and they will never overlap with the other application. The source port is dynamically chosen by the device, sending by the device, so it is a randomly generated. Source port is not fixed. Clear? When you open HTTP bbc.com, that is port number 80, right? If you say telnet 2.111.1.111, that is mean the port number 23. If you do SSH to 11111, for example, an IP address, that is port number 22. So your communication you are doing, like how we can keeping different application differently, because we are connecting to different application by using the different port number. So port is allow you to communicate over all these applications uniquely. So there is always source port and destination port. Source port, it's always randomly generated. It's not fixed. It's a system generated port. There are over 65,000 plus ports. Some are fixed, some of may not be fixed. If I go to internet, for example, if I type here TCP UDP port, do you see list of TCP UDP port number? Okay. And you see services name and transport layer. You see this port number 20, 21, 22, 23. If you go here, So you see, it explains you what is the TCP UDP port number. It also defines what are the well-known ports as well. Some of the ports are reserved and some of the ports are not reserved. So I think port from 0 to 123 they are reserved, and port onward they are not reserved. So they are used for well-known protocols, well-known application, for example. For example, 8 is used for HTTP. Okay. Similarly, 49 is used by the TACX server. NTP is used 37, 25 is used by SMTP, Telnet is used 23. So each application use different port number. So by using the different port number, it is possible for me to add computer or PC or sender and receiver to keeping the different applications separately. So for example, here we use the port number 1110 used by the email, electronic mail, HTML use port 80, instant messaging use IEM, which is used port number 531. The destination used to an application to service running on the server. A server can offer more than one service at a time, offering a web server and a 80 and port 20. So one server can simultaneously respond to port 80 and port 21 at the same time. These are the port number as we just mentioned. So well-known ports are 0 to 123. Those are assigned to already particular application. Registered ports like 1024 to 49.151 and 4915 These are private and dynamic ports. So dynamic ports come under this range. So you can see some of these ports. What I would suggest actually, at least if you CCNA level, please make sure some of the well-known ports, some of the protocol like FTP, what port is used, SSH, what port is used, SMTP, what port. So these are well-known applications because they might be, interviewer might initially ask you, can you please tell me at least 510 TCP port and the respective application. Okay. Similarly, TCP UDP, we already done that, right?